Today's lesson is Module 4, Lesson 8, Replacing Numbers with Letters. And today's lesson is an extension of Lesson 7. Today we will specifically be looking at 3 different properties of operations. The first property we're going to look at is the additive identity property of 0. Many of you probably already actually know how to use this property. But you don't know the definition or the mathematical vocabulary for it. So the definition is any number added to 0 will result in that number. So for example, 3 plus 0 is 3. Or if you have the variable a and you add it to 0, it would still result in a. The next property we're going to take a look at is the multiplicative identity property of 1. Again, this is something that most of you probably know, second nature. And it says that any number multiplied by 1 will result in that number. So for example, 6 times 1 is 6. Or if you had a variable such as m times 1 would equal m. The last property that we're going to look at today is the commutative property of addition and multiplication. The definition of commutative property is that 2 or more numbers can be added or multiplied in any order and the result is the same. So for example, 3 plus 2 is equal to 5, but also 2 plus 3 is equal to 5. An example of multiplication would be 4 times 3 equals 12, or 3 times 4 equals 12. Now, if you'll go ahead and take out your student book and open it up to Lesson 8, that is going to be 6.4 and then Lesson 8, Replacing Numbers with Letters. And in this first part, we are going to just explore some different things. So, for example, let's take a look at what they have here in our book, and it shows 4 plus 0 is equal to 4. We know that that is a true statement, so we're going to put a P next to that. That is true. 4 times 1 is equal to 4, so we're going to put a T next to that. That is true. 4 divided by 1. If I have the number 4 and I divide it by 1, how many 1s are in 4? 4. So that is true. 4 times 0, according to what we just learned in our notes, results in 0. That is true. And then the last one, 1 divided by 4 is 1/4, and that is true. So how many of these statements are true? All of them. How many of these statements would be true if the number 7 was replaced the number 4? So let's see. 7 plus 0 is equal to 7. Is that true? Yes, it's true. 7 times 1 is equal to 7. Is that true? Yes. 7 divided by 1, is that equal to 7? Yes. 7 times 0, that would be 0. That's true. And 1 divided by 7 would equal 1/7. That is true. So we would say, how many of them would be true? All of them. On to the next question. Would the number sentence be true if we were to replace the number 4 with any other number? So before we answer that, we're going to try something. I want you to do 0. Replace the 4 with 0. So 0 plus 0 is equal to 0. 0 times 1, that equals 0. So both of those are true. 0 divided by 1 is equal to 0. So that's true. So far, these sentences are all true because the first number and the last number are all the same. 0 times 0 would equal 0. That's true. Now 1 divided by 0 equals this is the one we can't answer. We cannot divide something into 0 groups. So if we have something, we can't make it into 0 groups. So this one would be the false one. So would the number sentence be true if it was placed by any number with any number? So that answer is no. If we replace the 4 with, what if we replace the number 4 with 0? So 0 does not work for division. The last sentence would be false. Okay, let's go on to the last one. Now it says, what if we replace the number 4 with the letter G? So G plus 0 is equal to, if I have G and I don't add anything to it, then I still have G. G times 1 is equal to G. G divided by 1 is equal to G, because if I make one group of G, G times 0 is equal to 0, because G groups of 0 would still be 0. And 1 divided by G is equal to 1G. So we would say all are true. Let's go on to the next page. The next one says, are these all true except for G equals 0 when dividing? That's our first question. Yes. So the only number that we know that will not work in every one of those number sentences is 0, and it just will not work in the last number sentence. Okay, so for this first example, we're going to do a little bit of practice with the additive identity. So it says, remember a letter in mathematical expression represents a number. Can we replace G with any number? So let's see. If I replace G with the number 5, so if I cross out G and I change it to 5 in both places, is that true? Yes. What if I have G plus 0 equals G, and I change this G to 17? And I have my plus 0. Is 17 plus 0 17? So yes, we can replace it with any number except for what number? We're going to say, actually, it will work even with 0. This one works even with 0. So choose a value for G and replace G with that number in an equation. What you observe? So we see that the original number does not change when added to 0. So they want you to give a few more examples. So for example, like 13 plus 0 is equal to 13. 229 plus 0 is equal to 229. It doesn't matter the size of the number. If you're adding nothing to it, then your number does not change. Will all values of G result in a true sentence? We just proved that that is yes. Write the mathematical language for this property below. Remember, this is the additive property of 0. And it says that any number added to 0 is itself. Let's go on to example number 2. In example number 2, we're going to look at the multiplicative identity property of 1. So in this one, they're looking at G times 1 is equal to G. It says, remember, a letter in mathematical expression represents a number. Can we replace G with any number? So let's try. Let's replace G's with 3 and fill in the rest of our equation. So 3 times 1, 3 groups of 1. So if I have 1 and 1 and 1 and groups of, so 1, 2, 3. Does that result in 3? Yes. So can we replace G with any number? Well, let's try replacing G with 0. So if I have G times 1 is equal to G, and I replace G's with 0, so if I have 0 groups of 1, so if I don't make any groups of 1, do I have anything? No. So can we replace G with any number? Yes. Choose a value for G and replace it with G. What do you observe? We see that the original number does not change when multiplied by 1. That's what we saw when we did this practice, that the original number that we started with did not change. Will all values of G result in a true number sentence? Well, we just did some practice here, and we saw that yes. And we can go ahead and practice another one. So if I do 17 times 1, if I make 17 groups of 1, how many will I have? 17. If I make 5 groups of 1, how many will I have? 5. Because each time you're only making a group of 1. Write the mathematical language. Remember, this is the multiplicative identity property of 1, and it states that any number multiplied by 1 will result in that number. Okay, last one. Commutative property of addition and multiplication. So what this is showing us is 3 plus 4 is the same as 4 plus 3. And 3 times 4 is the same as 4 times 3. So let's check that out. 3 plus 4 is equal to 7, and 4 plus 3 is equal to 7. And 3 groups of 4 is equal to 12, and 4 groups of 3 is equal to 12. So that's what those are showing us. It says replace all the 3's with the letter G. So if I cross all of these 3's out and replace it with the letter G, I'm sorry, it says A. I guess I just got used to using those G's in the previous one. So now it has A plus 4 is equal to 4 plus A, and A times 4 is equal to 4 times A. That's what that is saying. Now it says choose a value for A and replace it in each one of those. So now if I cross out the A's and I replace it with, let's say, 5. So 5 plus 4 is equal to 4 plus 5. And 5 times 4 is equal to 4 times 5. So let's check that and see if it is true. So 5 plus 4 is equal to 9, and 4 plus 5 is equal to 9. And 5 times 4 is equal to 20, and 4 times 5 is equal to 20. So what do we observe? We observe that they are true. All of those are true. It doesn't matter what order we put them in, they are true. Let's go ahead and go on to the next page. Will all values result in true sentences? That answer is yes. We just proved that. And so they want us to do some practice. So for example, 6 plus 4 is equal to 4 plus 6. How much is 6 and 4? They're both 10. And 4 and 6 is 10. Is 10 equal to 10? Yes. 4 times 6 is equal to 6 times 4. 4 times 6 is 24. And 6 times 4 is 24. Is 24 equal to 24? It says now write the equation again, and this time replace the 4 with the B. So at first we had A plus 4, so we're going to change that 4 to a B. So A plus B is equal to B plus A. And A times B is equal to B times A. Will all values of A and B result in a true number sentence for the first equations? Experiment with each value. So with this one, they want us to practice with changing A and B. So if I change A to a 2 and B to a 3, does that get the same thing? So let's try. 2 plus 3 is equal to 3 plus 2. 2 plus 3 is 5, and 3 plus 2 is 5. Let's try this one. If I change A and B to 2 and 3, leave my multiplication symbols. Are they the same? 2 times 3 is equal to 3 times 2. 2 times 3 is 6, and 3 times 2 is 6. Are they the same? So we say, yes, they are the same. Write the mathematical language for this property. The mathematical language for this property is commutative. So if we have A plus B is equal to B plus A, this is the commutative property of addition. And then we just say you can add in any order. And then if we have A times B is equal to B times A. This is the commutative property of multiplication. And it states that you can multiply in any order. And it doesn't change your answer. Now for this next example, they want us to replace all the 3's in this number sentence with the letter A. So every place where I see a 3, I'm going to write the letter A. So A plus A plus A plus A is equal to 4 groups of A. So I can see I have 1, 2, 3, 4 A's, and that's the same as 4 times A. In this next one, I have A divided by 4 is the same as A is the numerator and 4 is the denominator. Next, it says choose a value for A and replace the A in each number sentence. And what do you observe? So let's see what happens if we replace the letter A with the number 12. So the first one was 12 plus 12 plus 12 plus 12 is the same as 4 groups of 12. Did we make 4 groups of 12? Yes. Well, I know that 12 and 12 is 24, and this 12 and 12 is 24, and then 24 and 24 is 48. And then 4 times 12 is 48. Are these two things equal? Yes, they are equal. Will all values result in the same sentence, the same true sentence? So let's try. Let's replace it with 2's. So 2 plus 2 plus 2 plus 2 is equal to 4 groups of 2. Let's just try. 2 plus 2 plus 2 plus 2. So 2, 4, 6, 8. So this is 8. And 4 times 2 is 8. Is that the same? Yes. Now the one thing we haven't checked is the division. So let's go back and double check that. So the first one we should have had 12 divided by 4. Is that equal to 12 over 4? Well, 12 divided by 4 is 3, and 12 divided by 4 is 3. So yes. Let's try this one. And this one is 2 divided by 4 is the same as 2 over 4. So if I break 2 into 4 parts, it gives me 2/4, which is the same as 1/2. So that is still yes. Because if I have 2 and I have to break it into 4 parts, that's what that is saying. Okay, let's go on to the next question. Write the equation again, this time replacing 4 with the variable b. So remember we had replaced the others with a's. So now we're going to replace the b's with a's. And then we can also say a divided by b is the same as a over b. And the only thing that we know 100% is that b cannot equal 0. Because at the very beginning of our lesson, at the very beginning of our lesson, we learned that the only thing that could not replace was 0, because for division, we can't make 0 groups. Will all values of A and B be true sentences? And that answer is no. B can not equal 0. A can be replaced by any number. Okay, that's it for the lesson. Let's go ahead and take a look at today's assignment. For today's assignment, you are going to complete the exit ticket. The exit ticket, they want you to state what the commutative property of addition is and provide 2 examples. For number 2, you're going to do commutative property of multiplication again with examples. For number 3, you're going to do the additive property of 0 and then the multiplicative property of 1. So you're just going to give me, write out the definition and give me examples of each one. Remember, we did that together in our notebook. And on the back, again, they're going to have you give the commutative property of addition using these variables, using A and B. So how could you show the commutative property using A and B? For number 2, commutative property of multiplication using A and B. For number 3, state the additive property using the variable B. And number 4, state the multiplicative identity property using the variable B. And then for number 5, they want you to complete the table. So what would this result be to prove addition? So for example, 25 plus C is equal to C plus 25. And I'll go ahead and show you how to do number 1. So state the commutative property of addition using variables A and B. So we would say A plus B is the same as B plus A. So that's all they're wanting you to do there. Remember, if you have any questions, feel free to ask me, or feel free to pause and rewind this video as often as you need to.